Hello, folks. Well, this time I want to talk about something that I hope is kind of second nature for most of us by now, but I do want to make sort of some explicit points about this. So this is the idea of developing good, safe coding habits. So a whole bunch of bits and pieces that I want to run across here. Let's see how we go. Again, the idea is that when we're going through and we're writing code, we want to do that in a way that's going to minimize the likelihood of future problems. Right? So we're trying to write the code well in the first place, think about things that can go wrong as we're writing the code, and make sure we address that. We know that bugs are going to happen, there are going to be defects, there are going to be problems, but we want to minimize how many there are so that we minimize the stress that we've got when it comes to debugging later. We also want to make sure that when we're doing this, we're thinking about minimizing the impact for the user when these bugs do crop up. You know, if some kind of defect makes it through all of our testing processes and gets out and hits the client when this thing is live, we want to make sure that we do what we can to mitigate the problems that that's going to cause for them. So again, things that we're going to talk about as we run through this. A lot of this is going to be part of the standards for any kind of decent project or team or organization. So a lot of these things you will be expected to do, but even if it's not part of the standards, hopefully these are going to become good habits anyways. So first off, just in terms of the design, and this comes back to some of the ideas we were talking about in the design discussions, we want to keep the pieces simple. Simplify, decompose, abstract. Right? Use abstraction so that you don't have to focus on the inner details of something when you're just trying to use it. Right? Keep your computations, keep your logical statements simple and clear, abstract when you can. If you've got something complicated to do, break it up into clear, simple, logical steps so that each step is clear. Remember, even if you think of some really clever, complex way of doing something and it makes a lot of sense in your head right this instant, it might not make sense 6 months or 2 years from now when you have to come back and look at it again, or to somebody else that has to maintain this down the road. Again, they're easier to understand, they're less likely to contain subtle bugs if every step is clear and simple. You want to make sure that you use clear comments that are informative. Right? You don't want some huge mass of commenting where people are just simply not going to read it just because there's so much there. But you want the comments to be concise and you want them to be informative. You want them to point out things that the reader might not have picked up on otherwise. And of course, when you're going through and altering your code, you want to make sure you alter the comments as well so that they're up to date with whatever the code is actually doing right now. In terms of other areas, when you're looking at compiling something, right, whether it's using something like a makefile or by hand or using an IDE or whatever it might be, we want to make sure that we're taking advantage of the tools that are available to us. Right? Every compiler, every IDE has a variety of different error checking and warning options available to you. Make use of them. So for instance, for G++, when we're compiling things, we'll use the warnings all and warnings extra flags. And we'll pay attention to the error message that they generate, the warnings that they generate. And if it generates a warning, we're just going to say, that's not a big deal. We're going to fix it. Right? Every warning reveals some kind of weakness in your code. If your compiler generates warnings, fix them. Again, this is often going to be part of the standards for a team or for a project. It's part of the standards for this project. No warning is too small to ignore. Fix it. If you get into the habit of just letting them go, then when your code compiles, it's going to generate, slews of these warnings that you deemed unimportant. And then there's going to be a little one buried deep inside there that's important that you're not going to notice because this stream of other rubbish is going by. Or people are going to start thinking about your code as being, well, kind of cruddy anyways because it's always generating all these tons of warnings. So don't dismiss them. Don't just say, this isn't important. Fix them. Let's see, in terms of return values, right? Lots of functions or methods provide you with return values. Take advantage of them. right? The function is returning a value for a reason. It's giving you extra information. If it's got a return value, don't just call the function and discard the return value. Check it to make sure that it's reasonable for whatever you were expecting the function to do. Same thing with pass by value parameters. Make sure that whatever they are after a function call or after a method call is reasonable based on what your expectations were. Right? You're trying to make sure that you don't let problems slip by unnoticed. When you're getting data from the user or from another system, as early as possible, you want to make sure that that data is correct. And so one of the things that you're going to try and do is prevent incorrect data from coming in the first place. So if you're dealing with a user, then, if you're trying to get, for instance, a date from the user, then you don't want them to just type in the date as a text box. You want to do something like give them a calendar and let them select a date so that they can't possibly select a date that isn't a valid format. Right? They can't pick an invalid date. They can't pick the 32nd of January or something like that. Right? So you're going to try and give them clear information about what you're expecting them to give, and you're providing an input mechanism that maximizes their chance of giving you valid information. Right? When you're going through describing things to them, you want to make sure you describe it in a way that's absolutely clear. So if they're expected to enter a distance, you want to specify the units. Are you entering miles? Are you entering kilometers? You want to make sure that they understand what they're supposed to be supplying. Lots of big software disasters over the course of time have come from simple things like this, where the system is expecting, a distance in miles and the user enters it in kilometers just because the interface wasn't clear. Once you've got the data, again, you want to check it as soon as possible, as close to the point of entry as possible. You don't want the user to enter some data and then you don't use it for 3 days, and so you don't do the error checking on it for 3 days, and by then they have no idea what it was they entered or why or whatever it might be. So you want to check for any possible errors as close to the source as possible so it can get fixed immediately if possible. If you can, you want to minimize the impact of an error. So the typical example is filling out a form. Right? If the user has to fill out a 10-page form, you want to get them to fill out all 10 pages, hit submit, and then say, oh, you made a mistake in the very first field, re-enter the whole thing. Right? You want to make sure that you try and minimize the impact of an error wherever possible. So keep in mind that if you're interacting with other programs or interacting with files, right, the data in those has to be checked as well. Right? All things that we want to make sure that we catch. We want to anticipate the common errors that occur, and this isn't just in sort of the user input side of things. These are also the common programming errors that we might want to deal with. So some of the common things that are going to crop up are, if you're writing code for a function, it's pretty common for the parameter values to be something unexpected, something that's not a valid combination. Right? Something you were supposed to be passed a pointer to something and it's null. You were supposed to be passed a positive integer and they passed something negative. Whatever it might be, you want to make sure that you anticipate and install checking for kind of common errors. And some of the things that you can do to help minimize problems later are things like initializing your variables. Often you'll find that certain compilers will automatically initialize a variable to 0, whereas others won't. So you compile your program on one system and it works just fine because it's initializing everything to zeros for you, and you compile it somewhere else and it blows up because you were using a variable that wasn't initialized and has got some random garbage in it. Consider whether bounds checking and where bounds checking is going to be important, right? You want to make sure that if you're accessing array elements, you're accessing valid elements, accessing elements that have actually been initialized, accessing elements that are within range. So consider what needs to be done there. Right? Think about when you're using loops or recursion. Is there a possibility we're going to wind up with an infinite loop or runaway recursion here? Do we need to insert some kind of checking for those to prevent that situation from happening? Right? So it's all anticipating the things that we can predict have a reasonable likelihood of taking place. And again, coming back to the standards, a lot of these things are going to make it into the code standards for most teams and most projects. We'll come back and talk about this in a fair bit of detail, but coming back or picking reasonable standards, understandable standards, useful standards can make it a lot easier for you to maintain your code, read your code, understand your code, and the code that other people have written, or that other people are maintaining. And that, again, can make a big contribution to having reliable code. So these are all things that I want you to start trying to do when you're writing your own code and when you're reading code that other people have produced. Right? Look at the code that I produced for the demo project, and I'm sure there are places where it violates these ideas and these standards where I haven't inserted checking where I should. Right? Think about that and look at that. You know, what should have been done better? What could have been done better? And how? Or look at different things and say, okay, well, does it look like there was a reason for this design decision? Does it look like there was a reason for this decoupling decision? Think about why things have been done and was there a better way they could have been done? All right, I will leave it there for now. We'll come back with more ideas next time around.